Hello everyone, welcome to my channel. To those who come here for the first time, it's me, Engineer J. I am a civil engineer and I am also currently teaching as an engineering professor. We have this new topic in highway engineering. We have this unsymmetrical parabolic curve. We have already discussed, or we have already learned about the symmetrical parabolic curve, in which parabolic curve is designed to create a profile diagram, or to create a profile view of our highway. Again, it is need that we design our highway or our vertical curve properly in order to create a much convenient and a safe passage of traffic. And now we have this unsymmetrical parabolic curve, in which this is different from the previous symmetrical parabolic curve, but we will be applying the same procedure. And we have these two methods again, the same as with the symmetrical curve. We have to apply grade diagram and formula substitution by computing for the elements of our parabolic curve. Okay, so what is parabolic curve? What is unsymmetrical curve, to be specific? So we have a vertical curve is said to be unsymmetrical if the length of curve at each side of the vertex are unequal. So unlike in symmetrical curve, in which we knew that in symmetrical curve the length or our vertex is located a mid-span from PVC to PVT. But in unsymmetrical parabolic curve, as what you can see, we have unequal length from PVC to PVT. We have length 1, which is the location of our vertex, and length 2, which is the location of our vertex from PVT. But unlike again in symmetrical parabolic curve, we have equal length from the midspan. Okay, this one. So this is our location of our vertex. Now we have additional element in our unsymmetrical parabolic curve. We have this tangent. This is third tangent, in which we have grade 3. Therefore, we can say then that a unsymmetrical parabolic curve is just combination of two symmetrical parabolic curve. As what you can see here, we have this first parabolic curve in which the location of our vertex 1 is midway from PVC to V, okay? And we have this second parabolic curve in which the location of our vertex 2 is midway from V and PVT. Again, in unsymmetrical parabolic curve, this is just a combination of two symmetrical parabolic curves. So we will be using the same procedure by grade diagram, which is the easier compared to the formula substitution. But for formula substitution, we have this condition in which we have our length 1 times the grade 1 over 2. If that is lesser than the h, our h here is this from the point of intersection of this is our back tangent and this our forward tangent. Our h is from vertex, or the point of intersection of the two tangents, to the curve, that is the vertical height. And if our L1G1 over 2 is lesser than h, that means our highest point or our lowest point is located from PC. And that is, we have S1 is equal to G1 L1 squared over 2H. Now, if we have different condition in which our L1 G1 over 2 is greater than H, that means our highest point is located from PT, and that we have the formula S2 is equal to G2 L2 squared over 2H. Now, to compute for the length 1, this one here, we have this formula 2H L2 over L2 times G1 minus G2 minus 2H. So these are the formula that we can apply in computing for the elements of our parabolic curve. But again, the easier one is by using the grade diagram. Okay, now let's try to solve a problem. We have this example number 1. So we have a negative 2% grade meets 8% grade near an underpass. In order to maintain the minimum clearance allowed under the bridge and at the same time introduce a vertical transition curve in the grade line, it is necessary to use a curve that lies 400 meters on one side of the vertex of the straight grade and 240 meters on the other. The beginning of the curve, 400 meter side, is 10 000, that's the station, and its elevation is 200 meters. The first question is determine the stationing of the lowest point of the curve. The second question is determine the elevation of station 10 plus 080. Then determine the elevation of PVT. And lastly, if the uphill edge of the underside of the bridge is at station 10440 and at elevation 203.41 meters, what is the vertical clearance under the bridge at this point? Okay, so the first thing we do here is, of course, we create a curve. We draw the curve based on the given data. As what you can see, we have the first given grade, which is negative 2%. That is our back tangent, which means we are designing here a sag curve, okay, or a smiling curvature curve. So we have negative 2% and an 8% curve, okay. So we have this 8% curve, and then we have the length of the curve that lies on one side of the vertex of the straight grade, which is 400 meters, okay. So we have 400 meters from vertex and 240 meters on the other side. The beginning of the curve at the 400 meter side is 10,000 or 10,000. So we have here 10 plus 000, and the elevation is 200 meters. So this is our PVC and this is our PVT, okay. And then we have, so we have now this curve in which this red one, this is our parabolic curve. Now take note, this is a unsymmetrical parabolic curve because again the location of the vertex is 400 meter from PVC and 240 meter PVT. So we have unequal length from the vertex. So that means we have to create a additional tangent that cut our parabolic curve into two symmetrical curves. So we have this curve, and this is what we call, let's say this is our G3 or the grade 3. So we have now completed all the data in our drawing. So we can now proceed to our first question. We are asked to determine the stationing of the lowest point on the curve. Now take note, our G3 here is intersecting at this point, in which that is also the horizontal location of our vertex. Okay, so that means we can compute G3 here by using grade diagram. Okay, so again, our G3 intersects at this point, or the location of the intersection of our back tangent and forward tangent. So we have this grade diagram. So at PVC, we have a negative 2%, so we can go down to from our reference line. So we have at this point, we have here the coordinates negative 2. And then we go up because as what you can see, we have an increasing grade. Now the coordinates at this point is equal to the grade at this point, correct? However, we do not know yet what is the slope or the G sub 3 at the point of the vertex. So that means we let this as our variable G3. So later we will be solving the value of G3 because we will be needing that so that we can compute for the location of the lowest point. At PVT, we have already had the slope at PVT, which is 8%. That is the slope of the tangent line that is intersecting the point PVT. And then we have 8% there. So therefore, we have a coordinates on the positive y-axis. So therefore, we have 8% here. Okay, this is our 8. So we connect. And this is our grade diagram. As what you can see, we have 3 different grades here because we have a 2 symmetrical curve being connected. So again, this is not a straight line. There is a abrupt change of grade because we have a 2 separate symmetrical parabolic curve here. So the location of our lowest point here is on the point in which we have a 0 slope or a 0 grade. So therefore, this is the point of the lowest, or that is the lowest point on our unsymmetrical parabolic curve, and we have to determine the location of that point from PVC. So we have here this S sub 1. So we will be computing S sub 1 here. However, before we can apply ratio and proportion, we need to have the value of G3. So how are we going to do that? If you isolate this triangle, you would have this, we will have this diagram here in which the slope of this line is G3, correct? So if we draw a horizontal line, the angle here is G3. While this line, the slope is 2%, correct? Let's neglect the negative sign because we will be adding the 2 slope here. We will not be subtracting, so we can eliminate the negative sign and use the absolute value instead. Now, for this line here, we know that we have the angle here, which is G3. And so the angle of this is 8%, correct? That is the angle of this line. So that means we can say that if we will be solving this H here, you would have now on the side of PVC, you will have this length. Let's say this is our y sub 1 and y sub 2, in which we know that y sub 1 plus y sub 2 is equal to h, correct? So to compute for h, you would have, but let's say this, the length here, this dashed line is x. So therefore, to compute for y1, you would have tangent of theta is equal to the opposite over the adjacent. So that means our y is equal to x tangent of theta, correct? But since we know that this is symmetrical curve, so the location of our v1 to the vertex is 1/2 of 400. So therefore, this is L1 over 2, correct? Or that is 200 meters. So that means our x here is equal to L1 over 2, correct? And that is tangent theta. But we know that tangent theta is equal to the grade, correct? Because again, our grade is just the rise over run, okay? Our G is equal to rise over run. But to make it percent, we just multiply it by 100. And we know that tangent theta is equal to rise over run. So that means rise over run is equal to G3. Therefore, tangent theta is G3. That means our y is equal to L over 2 G3. Okay? Or G, or the grade. So therefore, our y1 here is just length 1 over 2. Then we have G3. Whereas our y2, this length here, is equal to length 1 over 2 G2. So that means this is our H, correct? So therefore, by simplifying it further, we have H is equal to, we can factor out L1 over 2, so we have here G3 plus G1. That is our H on the PVC side. But on the PVT side, we have our H is equal to, now if we let this height as y3, okay, and we let this height here as y2, so therefore we can say that H is equal to y3 minus y2, correct? So therefore our H on the PVT side, the equation is we have y3 in which that is L2 over 2, that is 1/2 of 240 because the location of this vertex 2 here is L2 over 2. So that means we have L2 over 2 times, to compute for y3, we have G2, correct? Minus L2 over 2, we have here that y2, that is G3. So therefore, our H is equal to L2 over 2, G2 minus G3. So we have now the relationship in which we equate the 2H. That means we have here L1 over 2, G3 plus G1, that is the grade, is equal to L2 over 2, G2 minus G3. So to compute for G3, we substitute all the available values here, in which we know that L1 is 400 over 2, G3 is unknown, plus G1 is a 2%. Okay, again, we eliminate the negative sign because we are adding angle here. And this equals to L2. We have 240 over 2. We have G2 is 8% minus G3. So by solving it further, we have the value of G3, which is equal to 1.75%. Now, what if we came up with negative value of G3? Let's say it's negative 1.75. That is for example. That means our G3 is decreasing. So we have negative slope. We have negative slope for G3. So that means this should be like this diagram here, in which negative 2% that is decreasing, and G3 is decreasing as well, like that, if we have negative G3. Okay? So we have incorrect assumption if that would be the case. But since we have positive 1.75%, so we have correct orientation of G3, which is increasing. Okay, so our G3 here is 1.75%. So we can now compute for S1 by just ratio and proportion, but take note, we have the length, which is 400 meters from PVC to V. So that means this length here is 400 minus S1. So by ratio and proportion, we have G3 over 400 minus S1, and this equals to 2% over S1. So we have G3, which is 1.75 over 400 minus S1 is equal to 2 over S1. So we have our S1 here, which is equal to 213.333 meters. But since the question asks for the station of the lowest point, so we add the station of PVC. So we have the station of the lowest point, which is the station of a PVC plus S1, in which we have 10,000 plus 213.333. That means we have here 10,213.333, or that is 10 plus 213.333. So this is now our answer. Again, this is the station of the location of our lowest point. Now for the second question, we determine the elevation at station 10 plus 080. So 10 plus 080 is 80 meters from PVC. So let's say our 80 meters is at this point. Okay? So this is our 80 meters from PVC. And the station at this point is 10 plus 080. So we have to apply the area. Okay, so as what you remember, to compute for the vertical distance between 2 points, to just compute the area of the grade diagram between the 2 points. So therefore, we will be computing this area here, in which that is the location of 10 plus 080. Since we know that the vertical height C, or the difference in elevation between 2 points, is equal to the area of the grade diagram between that 2 points as well. So we will be computing this area, and again that area is equal to C, or that is our difference in elevation. So in this case, we compute for our area, which is our C, or the difference in elevation, and this equal to, now again that is a trapezoid, so we have 1/2 times the height, 1 plus height, 2 times the base, correct? This is the area of a trapezoid. So we have 1/2. Our H1 is this one here, which is 2%, or we can set that as 0.02. Our H2 is yet to be solved, so we have to apply ratio and proportion. If this is our 80 meters, So therefore, this distance here is equal to 213.333 minus 80. And that is equal to 133.333. So we have ratio and proportion in which we have 2 over 213.333 equals to H2 over 133.333. So we have H2 here, which is equal to 1.25%. So that means we have the height 2, which is plus 0.0125, okay, times the base. Again, our length is 80 meters. That is the length of our trapezoid. So we have a C here, which is equal to 1.3 meters. So that is the difference in elevation between PVC and the point of location of 10, 0, 80. So our C here is 1.3. Now to compute for of this elevation, you just subtract 1.3 to 200 meter because the elevation of PVC is 200 meters, correct? So therefore, the elevation of 10 plus 080 is equal to 200 minus 1.3, which is equal to 198.7 meters. So we have now this answer for letter B, or that is number 2 of the problem. Okay, so let's now proceed to number 3. So we are asked to compute for the depth for the elevation of PVT. So we compute for the elevation of PVT. So basically, we can apply trigonometry into this one. We just need to compute first the elevation of V, or the vertex, by computing this height. So we know that PVC is 200 meters. So by subtracting this height to V, again, this is our vertex, we could compute the elevation of our vertex. Okay? And then we add this height from V upward. So if we have the elevation of vertex and then we add this Y here, which is the height from V to this point, so we could compute the elevation of PVT. So that's would be the easier approach. But you can also proceed to our grade diagram. So you can add and subtract the area so that you would have the difference in elevation between PVC and PVT. But in this case, I would prefer this approach here. So we can compute the elevation of the vertex here, and we know that the slope here is 2%, correct? So we can say that, and we know that this is 400 meters, and this 440 meters, correct? And this 8%. So that means we can compute this H, or this height number 1, let's say, that is we know that tangent theta is equal to opposite over the length. Okay, so we have tangent theta is the grade, H1 is the height, our length is 400, so we have our H is equal to the grade, 2% times 400. You express 2% here as a decimal, so we have the H1, which is 8. Okay, that's 8 meters. So therefore, you would have the elevation of the vertex equals to 200 minus 8, and that is 192 meters. So our elevation here is 192 meters. And then you add Y. To compute for Y, you have Y is equal to 8% of 240, correct? So you have the Y, which is 19.2 meters. So therefore, you would get the elevation of PVT is equal to 192 meters plus 19.2 meters. This would give you 211.2 meters. So this would be now the elevation of PVT. So I just used the concept of trigonometry into this one. So this is our question number 3. Now for our last question, if the uphill edge of the underside of the bridge is at station 10 plus 440 and at elevation of 203.41 meters, what is the vertical clearance under the bridge at this point? If we have the underpass, okay, if you have a bridge here, the uphill edge is this one. Okay, that's our uphill edge, in which the location of this point is 10 plus 440 and the elevation is 203.41 meters. So we are asked to compute for the clearance. So from this edge to the point of our curve. Okay, so we will be computing, let's say this is our H2. Okay, so we will be computing for H2 here. Again, the length is 10 plus, the station is 10 plus 440. Therefore, from V to that edge is 40 meters. So we have the length here, which is 40 meters. Again, that is from the vertex to the uphill edge. So the first thing we do here is we compute for the elevation at this point. So we compute the elevation, then we subtract the elevation of the uphill edge, then we would compute the clearance of the road or the underpass. So to compute for the elevation of this point, which is 10 plus 440, so we can actually use the grade diagram. So we compute the area between PVT and the point 10 plus 440 so that we can compute their difference in elevation. So this is the one that we need to compute first, that is C. And C here is equal to the area of the grade diagram between the 2 points. Since we have already computed the elevation of PVT, which is 211.2 meters, correct? So by subtracting the value of C, then we would have the elevation of 10 plus 440. So we have our C, which is the area of the trapezoid. We have 1/2, that is H1 plus H2 times B. This is our H1, this is our H2, and this is our B. So we have C is equal to 1/2. Our H1 is 8. Our H2 here is unknown. So we have to... Now to compute for H2, we can create a new triangle here, which is this one, in which this height is 8 minus 1.75, correct? So we have here 8 minus 1.75, that is 6.25. And let's say this is our A. So ratio and proportion, we would have 6.25 over the length is 240 meters, correct? So we have 240, that is the length 2, equals to A over, now we do not know the length of this, but we have the station 10 plus 440. That means we have 40 meters from the vertex. So we have here 40 meters. So that's A over 40. So therefore our A here is equal to 1.042. Okay? That is our A. But since we are computing here for H2, we add 1.75 and 1.042 so that we would compute the entire H2 here. So we have H2 is equal to 2.792. That is in percent. Okay, so we have here 2.792, but we can express this all into a decimal. So we have 0.08 plus 0.02792 times our B, that is 240 minus 40, that is we have 200. Okay, because we have 240 meters as the total length, but we have 40 meters from vertex, so we have here 200 meters. So our C is equal to 10.792 meters. So the difference in elevation between the 10 440 and PVT is 10.792. So again, this length is 10.792. So to compute for the elevation of that point below the edge of our bridge, so we have elevation of station 10 plus 440 is equal to the elevation of PVT minus C. This equals to, we know that the elevation of PVT is 211.2 minus C is 10.792. This is equal to 200.408 meters. So therefore, to compute for the clearance, that is, we have the elevation of the uphill edge minus the elevation of PVT. So we have 203.41 minus 200.408 meters. So therefore, the clearance is 3 meters. So that means all the car with a height of less than 3 meters can safely pass through the underpass. However, for vehicles that has a height of more than 3 meters should not be allowed to enter the underpass. So that ends our lesson on unsymmetrical parabolic curve. So if you wish to learn more about parabolic curve, so you can look for another problems resources in the internet. So we have so many available resources there. And that ends our lesson. So I hope, guys, that you have learned something. And as what you can see, we are applying here the theory, the principle of trigonometry and geometry. So we do not have an exact procedure to follow. So we apply all the prerequisites knowledge that we had. Okay, thank you guys for listening. See you in my next video, but please don't forget to like this video and subscribe to my channel. Thank you guys, and God bless.